Hello and welcome. In last lecture, we discussed about risk analysis and the four different ways how you do the risk analysis, right? So under the four stages of our risk management process, the first one being risk analysis, the second one is risk evaluation and control. So in today's video, we'll discuss risk evaluation control in more detail. So what is risk evaluation? Now you have already got all your hazards and hazardous situation from PFMEA or DFMEA that you guys use in your company, and you have a list of hazards and hazardous situation, right? And you might already have a risk matrix and you know how much of a harm that line item can give to the patient. So now in this step we evaluate the risk. And risk evaluation involves comparing the estimated risk with pre-established criteria to determine whether they are acceptable or not, right? Risk control involves implementing measures or steps to reduce unacceptable risk to an acceptable level. So what does that mean? So if your device, for example, if it's a heart monitor, if it's giving 1% fluctuation, all right, if your heart was 88 heartbeats per minute, if it's given 88.5, maybe you think that it is still an error from your device, but it's not that much of an error, right? So maybe you think of that plus minus 0.2% as a low risk. But if your device is supposed to record 85, and if it's giving you 140, then that's no good, right? So in that time you need to do a risk control to basically get it figured out. So risk evaluation is once a risk associated with medical device have been eliminated, they need to be evaluated to determine whether they're acceptable or not, right? This is done by comparing the estimated risk with the pre-established criteria for risk acceptability. This criteria should be based on your company's risk acceptability policy as well as applicable regulation and standard. So what I mean by here is if you had like a catastrophic, one of the risks could lead to catastrophic harm to your patient, right? If you have reduced the risk, now you have to revisit and evaluate that risk to see if the new risk, because you can never eliminate it, but if the new risk is acceptable or not, right? So to give you guys an example, a manufacturer or a company that produces surgical robots might have a risk acceptability criterion that states that risk of a serious injury to a patient is must not be greater than 1 out of 10,000. So what that means is every 10,000 patient they administer, only one can have harm, not more than that. So if they have circumstances or when they're in the field, when they're selling this product, and if they're finding that they have 2 or 5 out of 10,000 people that are getting hurt from their product, then that risk is unacceptable. So now they need to go back and they need to control that risk, because from their documents, from the risk metrics and their analysis, they said, okay, 1 is only acceptable, not 5, right? So now they need to control that risk. So that brings me to the risk control. Risk control, what does it mean? If a risk that is determined to be unacceptable, that is like no, the company must implement risk control measures to reduce the risk to an acceptable level, right? ISO 14971 recommends using the following control options in terms of priority. So ISO basically says, hey, if the risk is unacceptable, what do you need to do? Maybe you need to do a design change, or how do you need to proceed, right? So the first thing you always need to think when you're doing risk control is inherently safe design and manufacture. So basically your design, from the design it needs to be safe, and when you're manufacturing it needs to yield you safe product. That's where you need to start, right? This is a preferred option because it eliminates and reduces the hazard itself rather than relying on additional safeguards or behavior, right? Or user behavior. So if there was a sharp edge in your device, if you could go back to the design and just take that out, then that hazard is no longer present. Versus if you put a band-aid or tape around it, that sharp edge will still be there, but you reduce the hazard by basically putting a cover on it, but that didn't eliminate. So always the first thing is maybe you can do a design change, right? Or a change in manufacturing process. So an example would be a surgical equipment that could design with a safety guard to prevent accidents, when accidental cuts, right? So if you see like a saw blade and stuff, I don't know if you guys have seen, that's also a medical device. They use it in doing autopsies and stuff. It cuts through the bone, but if you were to put your hand on it, it has a redundant safety switch that basically kills it senses that this is flexible, our skin is flexible, so it stops the saw from working, so your hand is prevented. So that actually comes from the design of that instrument, right? So you always need to, when you're trying to reduce the hazard, you always need to think from that first principle. And the second one would be protective measure in the medical device itself or in the manufacturing process, right? So this involves implementing safeguards in the device or manufacturing process to protect users from any kind of hazard. This option is used when it's not possible to completely eliminate the hazard through inherently safe design. So what I mean by this, so there's no way that you can get that sharp edges from your design, from the design changes. You kind of need that curve for your medical device to work, for example. Then what do? You maybe use in a manufacturing process, you put a lot of QC checks to make sure that the sharp edges are maybe trimmed down a little, and 100% visually inspect them as a QC process and stuff like that, right? To give you an example, in the infusion pump, they could put in an alarm system to warn user if the device malfunctions, right? So they might not be able to control the doses that's going to the people, 2 milliliter or 100 milliliter, but if they think that it's getting malfunction, they could alert the user the problem so that they can take corrective action. Maybe if a lot of insulin went through, at least they will be aware of the situation and they can take care of their health. So that's basically going through, they can fix in the design, but they're fixing in the manufacturing. So the third one that we have on the risk control, on the process flow that we have, is information for safety and training. So you can do a design, you can change it in the production, then you need to let your users know about the information and the risk associated with the device, right? And how to use it safely. This option is usually used in conjunction with the risk control measures such as inherently safe design and protective measures. So this one is basically IFUs. A lot of companies give IFUs, information for use, that hey, this is how you're supposed to use our product. If you're supposed to use the switch, heart monitor switch once, only press it once. Don't press it 5 times, otherwise you'll reset the system. Stuff like that, right? You can let your patients or user know about that. One example that I can give, a real life example, would be of a company that sells or makes an X-ray machine could provide users with clear instructions on how to minimize radiation exposure, right? This would help to reduce the risk of exposure to the patient and the healthcare professional using the machine. So this is a classic example because X-ray machine is supposed to give X-ray so that they can see the internal part of the body, right? But X-rays are inherently bad, so they cannot just take out the X-ray from the device, otherwise they don't have a medical device. So at least they can let the patient or the user know how to use it so that they minimize the exposure in unintended areas, right? And the fourth one is verification of risk control measures. Our fifth one, it is important for the companies to verify that the implemented risk control measures are effective in reducing the risk to acceptable level as possible, right? This can be done through several methods such as testing, analysis, or verification and validation studies. After you put a safeguard in, let's run a validation studies of 200 parts per production. Did you effectively get rid of the issue that you're having, right? So you can do a lot of studies to make sure that your risk control actually worked. So that is all I have for evaluation, risk evaluation and control. To summarize, risk evaluation and control are very essential stage in risk management process. By carefully evaluating this risk and implementing appropriate risk control measures, your company can ensure that your medical device are safe and effective for your patients and it does what it's supposed to do. So in next videos we'll discuss about the risk management review and post-production activities in more detail. I hope you found this very important and helpful. This is a dense topic, right? The entire risk management process is basically based on risk analysis and risk evaluation, but all this risk evaluation and control, but all the bullet points that I gave you guys, if you follow them properly on how to do your risk control, like inherently safe design, or do something in your production floor, right? Or give information for use to your patient, and verify that any risk controls you used did actually work, right? So if you follow those kind of stuff and if you have documents that you can use, it'll be helpful to actually evaluate the risk and control it. And on a side note, usually a lot of companies does not just say, oh, this is my document for risk analysis, this is my document for risk evaluation. They have documents called pre-hazard analysis, right? Basically that is before you have a DFME or PFME. They look at how the device is supposed to be used and how can it be used incorrectly. So they get some harms and hazardous situation from that, right? And not just that, so they use that document and they go and do clinical trials. They see in the field, okay, this is how our device has been used. Maybe they'll get some complaints on the field from clinical trials saying that, hey, we tried to administer our device using this process and it didn't work, or our patient had harm, for example, right? So in that kind of scenario, you will get more harms from the field and they'll report it to you. So with those information, you can kind of make a document such as pre-hazard analysis document and list all those hazards, right? And then for the risk analysis and even risk evaluation and control, risk evaluation, I should say, people most times they rely on PFMEA if it's a process. If you have something in the production, you basically write line by line the steps of the production, right? From this steps in the production, what harm can come to the patient. So you try to brainstorm that, and is that harm gonna be high risk or low risk? And if it's high risk, then you have to find a risk control measure for that, right? So you list through the PFMEA, and in the design you do the same thing, starting from the initial design, right? Sub-assembly to the assembly level. Does it have any impact? Does it have any risk? So basically from that you'll get a tons of hazard and hazardous situation, and based on that you look at the severity of the harm that it causes and how likely that hazard is supposed to happen, right? If you have something that goes in the eye, maybe people feel uneasy a lot of times, so the likelihood of uneasy is a lot, right? But does people get infection from your product a lot because of that uneasiness? That's if the severity of the infection is a lot and it is caused by uneasiness in the eye, that's a high risk for you. So you need to try to reduce those risks. And I have a separate video on how to create PFMEA, DFMEA. It's not going to be this type of video. I demonstrate you guys in via my computer and show you exactly how to make PFMEA, DFMEA, which I'll list in the lower sections of this lecture module. And that's very important. And risk matrix is very important because that helps you quantify which risk is going to be high risk, which risk is going to be low risk, because you'll only have a severity and you'll have how likely it is to occur, right? So you'll always go back to the risk matrix and see if my severity is 2 and likely to happen is, for example, 1, then that's considered low risk. If my severity is 2 but it happens all the time, if it's very likely to happen, then maybe that's a high risk, right? So, and the reason you classify low risk, high risk, and medium risk is because that way you'll know that if it's a low risk, maybe you don't have to do any risk controls. Maybe your company says that, okay, low risk things we can just leave it as it is because we don't want to create more variables in our product. But if it's a very high risk or medium risk, we want to implement risk control measures so that we can reduce the risk, right? So that's basically in short. We covered majority of the thing, that is risk analysis, risk evaluation and control. In the next lecture we'll talk about the post production activities, and that is also very important, like how I was talking about what happens in the field. You get the data back and you plug it into your risk management and get more hazard and hazardous situation that you never thought about but happened in the field. So that's all comes from the post-production activities, right? So that is still on the track. So for that we'll visit our final module, which is post-production activities. So I'll see you guys in that next lecture. Thank you.